So write down the next heading, the new topic, refraction through rectangular glass slab. Refraction through the rectangular glass slab. डायग्राम ड्रॉ कर लेते हैं रिफ्रैक्शन के लिए हम लोग रेक्टेंगुलर ग्लास स्लैब के लिए. And this topic is a very important topic. Very important topic. ठीक है. Now let us consider this is a glass slab. Let us consider on this normal. ठीक है, ये मेरे पास एक नॉर्मल है. And this is the path of, this is the actual path of the ray. Actual path. This is incident ray. Angle of incidence. Fine. And this is air medium, and air medium is what?
Rarer.
Air medium is rarer medium. ठीक है, कौन सा मीडियम रहेगा ये? रेयरर मीडियम रहेगा. ठीक है. नाउ and this glass medium is denser, and this air having a refractive index n1, and this glass having a refractive index n2. Fine. Light is traveling from rarer medium to denser medium, so the light will move or bend towards the normal. So this light ray will bend towards normal. This light ray will bend towards normal. So here AB is the incident ray and BC is the refracted ray. Fine. So what are the nomenclatures are here? The nomenclatures are, that is, AB is incident ray and BC is what? Refracted ray. Okay. So, and also after the second interface, this is first boundary and this is the second boundary of the glass. Fine. So now this is the second point of incidence. Draw the normal on the second point of incidence. This normal is N1 and this normal is N2. Fine. So please tell me the this rectangular glass slab P, Q, R and S. So PQ is equal to RS. Yes or no? PQ is equal to RS.
Yes.
Okay. And normal 1 and normal 2 makes 90° on the surface. Normal 1 makes 90° on PQ. And also, on RS, normal number 3, normal number 2 also makes 90°. So if PQ is parallel to RS, then please tell me normal 1 is parallel to normal 2 or not?
Yes, sir. Yes, sir.
है ना? Normal भाई भाई. Fine. So normal भाई. It means on the parallel surfaces, normals are always surface parallel. Fine. So this is what? This is incident angle 1. This is what? Refraction angle. This is what? Refraction angle. Fine. R1. Let's say I can say it is R1. If this is R1, then this angle is also R1. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Fine. And finally the ray will emerge out. अब रे जो इमर्ज होगी इसका पाथ हम बाद में ट्रेस करेंगे, ठीक है ना। लेकिन चलिए नॉलेज के लिए आप देख लीजिए बेसिकली होता क्या है। दिस रे इज इमर्जेंट रे। इस रे को हम लोग कौन सी रे बोलेंगे? इमर्जेंट रे। दिस वी कॉल इट इमर्जेंट रे, ठीक है ना। या इमरजेंस रे या इमर्जेंट रे बोलेंगे। इमर्जेंट ray. So this is what? This is E, angle of emergence. This is E means angle of emergence. Fine. And these two, actual path and emergent rays, are parallel to each other. Emergent path and emergent ray path and actual path are parallel to each other. And this one, keep in mind, this one जिसको मैं अभी ड्रॉ करने वाला हूं, यहां से सी पॉइंट से जो हमने परपेंडिकुलर ड्रॉ किया हुआ है, दिस पॉइंट, दिस, ठीक है ना, दिस इज व्हाट? लेटरल डिस्प्लेसमेंट। लेटरल डिस्प्लेसमेंट। फाइन। इसको हम लोग बोलते हैं लेटरल डिस्प्लेसमेंट। इसको हम बोल सकते हैं ए बी सी, दिस इज डी पॉइंट और दिस इज E point. So C is the lateral displacement. It means लाइट जो है वो मीडियम की वजह से कितना शिफ्ट हो गई, लिटरली शिफ्ट हो गई, ठीक है ना। एक होता है इन्वर्टेड और एक होता है लेटरल। लेटरल का मतलब है परपेंडिकुलर शिफ्ट होना, ठीक है ना, परपेंडिकुलर शिफ्ट होना, दैट इज कॉल्ड लेटरल। दिस डायग्राम इज वेरी इंपॉर्टेंट फॉर बोर्ड एग्जामिनेशन। अब मैं यहां पर स्नेल्स लॉ की बात करता हूं, ठीक है। अब एक चीज और दोबारा से करेंगे, जहां रिफ्रैक्शन है वहां स्नेल्स लॉ है, ठीक है। और एक और चीज यहां पर, दैट इज सी डी। सी डी इज इमर्जेंट रे। ये सभी लेवलिंग आप प्रॉपर करेंगे, ठीक है। एंड वन मोर थिंग, एक छोटी सी चीज और रह गई। ये वाला एंगल दिख रहा है आपको, एंगल ई बी सी, एंगल ई बी सी।
Yes, sir.
This is angle of deviation. Angle of deviation. That is how much light is deviated from its original path. The angle of deviation tells about that how much the refracted ray is refracted or deviate from its actual path. That is what angle of deviation. And its value is I1 minus R1. ये पॉइंट समझ में आ गया एंगल ऑफ डेविएशन की वैल्यू?
Yes, sir.
Why? Because of vertically opposite angles are equal. This is normal N1 and this is the actual path, angle of incidence. Then this is also the angle of incidence and this one is the refracted ray. Fine. And this is the angle of refraction R1. So what is this angle? I1 minus R1. Okay, please dear, tell me how many interfaces are here? Interface number 1, interface number 2. So because of two interfaces, how many refractions are possible?
Two.
Two.
Two refractions are possible. So how many times you will use Snell's law?
2 times.
Two.
Very good. From rare to denser and from denser to?
Rare.
Rare.
Very good, very good, very good. Now apply Snell's law at interface 1. First interface, that is rarer to denser. Okay, so sin I1 upon sin R1 is equal to what I have to write here, N1 upon N2 or N2 upon N1?
N2.
N2 upon N1.
Very good. It is N2 upon N1. Fine. This is your equation number 1. This is your equation number 1. Now apply Snell's law at interface number 2. That is denser to
Rarer.
rarer. Now please tell me, for the interface number 2, the BC ray, please focus on this diagram. This BC ray act as incident ray or not? Please tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
ठीक है, सभी को क्लियर है ये पॉइंट? This BC
Yes,
ray
sir.
act as incident ray for the interface number 2, and while the CD ray act as refracted ray for the interface number 2nd. Okay, so keep this thing in mind. So here BC act as incident ray for interface 2nd. Hence R1 is incident angle for interface number 2. ठीक है, now अब समझ में आ गया ना why we are saying that R1 is the incident angle for the second interface.
Yes, sir.
Yes, sir.
So now apply the Snell's law. What is Snell's law? Sine of incident angle. So what I need to write? I need to write sine I1 or sine R1 first.
R1.
Very good. And upon sine refraction angle. So the emergence angle E is act as a refraction angle. ठीक है ना? So E is what? Angle of
Sir.
emergent. Yes, please.
Sir, angle of emergent और angle of incidence equal होंगे ना?
अभी वो ही तो निकाल रहे हैं बेटा हम लोग. ठीक है ना, उसी को हम लोग प्रूफ करने वाले हैं अभी. ठीक है.
Yes.
So here, and what we need to write for second interface, rare to denser or denser to rare?
Denser to rare.
Denser to rarer.
So please tell me, what is the relation of refractive index?
N1 upon N2.
Very good. N1
N1 upon
N1.
N2.
This is equation number 2. Now, I can write here from equation number 2nd, I can write here sine E upon sine R1 is equal to N2 upon N1. May I write this?
Yes, sir.
Reciprocal कर दिया. Why we are doing here reciprocal of equation number 2? Because of if I am reciprocal this, then RHS will be N2 upon N1. When it is N2 upon N1, then I can easily compare with the equation number 2, equation number 1. Okay, everyone?
Yes.
Yes, sir.
Now comparing equation 1 and 3. May I write this? Sine I1 upon sine R1 is equal to sine E upon sine R1. May I write this?
Yes, sir. Yes, sir.
Fine. Now is there any cancellation here?
Yes, sir. Denominators.
Denominators are cancelled here. Fine. So this will sine I1 is equal to sine E. Okay. So implies that if I compare the angles, then I1 is equal to E. So the angle of incidence is equal to angle of emergence.
Yes.
So this concluded that the emergent ray will parallel to the actual path.